Welcome to this presentation on validation of a locally designed computed tomography dose phantom comparative assessment against a standard acrylic phantom for dose accuracy and consistency in EDO and delta states, Nigeria. This research was conducted by Eseka et al. And published in Volume 5 Number 2, 2025, July to December 2025. Today, we will explore the key findings and contributions of this important work. Let's begin by understanding the problem this research addresses. Computed tomography, or CT scans, are becoming increasingly common around the world. This is also true in Nigeria. While CT scans provide valuable medical information, they expose patients to higher doses of radiation than standard X-rays. Because CT scans use more radiation, it is important to carefully monitor and optimize how they are performed. One way to do this is by using CT dose phantoms. These phantoms act as a reference to check radiation dose levels and scanner performance. This study took place in 4 CT centers in Nigeria. 1 was state-owned, and 3 were privately run. Researchers compared a standard phantom to a locally made phantom. Standard phantom was made of acrylic, while the local phantom was constructed from bent sheets and filled with water. Both phantoms were scanned using the same methods at each CT center. Researchers used ionization chambers to measure the radiation dose levels in each phantom. The study found some differences in dose measurements between the standard and locally made phantoms. For head CT scans, the largest difference was about 7.18. For body CT scans, the largest difference was around 3.25. There were also some differences between the dose values displayed on the CT scanner console and the measured dose values, especially for head CT scans at one of the centers. The research showed that the locally made phantom measures radiation doses similarly to the standard phantom. This is good news because it means clinics that cannot afford standard phantoms can use these alternatives for quality control. Different CT scanners and settings were used in the study. This shows the locally designed phantom can be utilized in a range of real-world situations. It is important to remember there were some differences, especially with head scans at one of the centers. This study shows that the locally designed CT dose phantom is a useful tool for checking radiation doses in CT scans. Although there were some small differences compared to the standard phantom, these differences were not statistically significant and fell within acceptable limits. This makes the local phantom a reliable option, particularly for clinics with limited resources.